Hello everyone, I am Prem Kumar. Welcome to Olympiads Math Academy. Today I am going to discuss with you the very interesting theorem, Ptolemy's Theorem. Okay. So Ptolemy's Theorem, what is the statement says? In a cyclic quadrilateral, the product of the diagonals equal to the sum of the products of pairs of opposite side. So what is the meaning actually? If you have a quadrilateral, cyclic quadrilateral, let's take a circle. You have to insert the quadrilateral inside. That is a cyclic quadrilateral. Let's take A, B, this is C, this is D. You can extend it this C to D. You have to extend it, right? C to D you can extend and you can join this. Let's take this is M, right? Okay. So why we are extending this? Because we need to prove that the product of the diagonal. So which one we can take here? Let's take BD and AC or the diagonals of the cyclic quadrilateral. Okay. So what actually we need to prove? The product of the diagonal. That means AC into BD is equal to the sum of the, you can see sum of the product of pair of opposite side. That means AB opposite DC, that means AB into DC plus AD opposite BC, AD into BC, right? So we have to prove this. This is your Ptolemy's theorem. Then how to prove this? You can see first you have to understand what is the properties of the cyclic quadrilateral. The first observation you can see, sum of the opposite angle in a cyclic quadrilateral is supplementary. That means what? Angle, first observation, angle A plus angle C is equal to 180 degree. Second observation, angle B plus angle D is equal to 180 degree. This is first one. Second one, you can see the exterior angle of a cyclic quadrilateral. Here, what is the exterior angle? This is your exterior angle is equal to the opposite of the interior angle. That means third point, angle ADM is equal to angle ABC. All are equal because exterior angle of a cyclic quadrilateral is equal to opposite of the interior angle. Okay, you need to understand these 2 points, right? So how to prove this question? So we have to prove through the similarity of the triangle. So what is mean by similar triangle? If two triangles are similar, you can see this is smaller triangle, suppose this is bigger triangle, right? The corresponding angles should be equal. That means if you drag any vertices, it will not change the shape, the same shape, but different size. Different size here is what? If you drag any vertices, the size will be different. That means corresponding sides are proportions. Understood? That means, so one of the sides of the triangle, some scalar times, the first triangle sides. Understood? That's why we are telling that ratio of the sides are proportions, right? Okay, fine. Now, how to prove this? Which two triangle you have to take? You can prove the statement. First, we have to write the statement first. What is the product of the diagonal? You can see the green color. To prove is what? To prove AC into BD equal to AB. AB is the one side. That opposite to that side is what? DC. DC plus AD opposite is what? AD opposite BC, right? We have to prove this only. The product of the diagonals equal to the sum of the product of the opposite pairs, right? Okay, how to prove this one? For that, first I am taking triangle CAM, triangle CAM, and triangle, which triangle I am taking? BAD you can take. triangle BAD. So if you take two triangles, how you can prove that the two triangles are similar? By angle-angle similarity. So for that we need to do some construction. What is a construction? Let's see that. One angle you can take that angle in a same line segment. One more angle is required. For that we need to do some construction. What is the construction? Construction. Okay. So take, what is the construction here? Let's take angle DAM. DAM is equal to angle BAC you can take. Angle BAC. Let me take another color. Let me take, this is 1. DAM you can call as 1. Right? Angle 1 is equal to 2. You can take. Just you can take angle 1 here is what? DAM, and BAC you can take angle 2. Clear? So this is the construction. Okay. Take these two triangles CAM and triangle BAC. If you take, the first observation you can see in the screen. Which one I can take here? If you have a circle, this is your common line segment, right? Angle in a same line segments are equal. This is A, this is B, suppose C here. This is suppose D. These two angles are equal. Angle in a same line segment. Because A and D are moving point on the circle, right? So this is just all these two triangles are coming from the same base BC. So those angles are equal, angles in a same line segment. So you can take triangle CAM and triangle BAD, which is common here. You can see, we can take this one. We can take this angle is same as, which one we can take? This angle, right? BAD only we are taking, no? So these two angles. So which is a common base here? Yes. Common base angle is what? Base side is AD. So ACD is same as ABD. Both are same. Right here first. ACD is equal to angle. You can see ABD you can take. ABD. So angle in a same line segment. Angle same line segment or equal. Clear? Okay. So first observation we done. Next, which triangle, angle we can take here? You can see one observation. CAM is there. No, you can see angle CAM. How to write? CAM. CAD plus DAM. Angle DAM we can say, right? Already know the DAM we call as angle 1, right? Okay, no issue. CAD. Let me take this angle is 3 you can take, right? CAD you can take. That means CAD you can say angle 3. So DAM is what? DAM. Angle 1, right? Angle 1. Clear? Now, from this what we can conclude? You know that angle 1 is same as angle 2 by construction. Angle 1 is equal to angle 2 is there by construction. Angle 3 plus angle 1, how to write? Angle 2. Okay. From these two things, what we can conclude? Angle CAM is equal to, you can say angle CAM is equal to what? Angle 2 plus angle 3. Angle 2 plus angle 3. What is angle 2 plus angle 3? You can see in the screen. Angle 2 plus angle 3 is same as BAD, correct? BAD. Okay. So therefore, by angle similarity, we can say that the first one is angle in the same line segments are equal. Second one is, you can see angle CAM is equal to angle BAD. So by angle similarity, we can say triangle. Which two triangle? CAM and triangle BAD. CAM and triangle BAD or similar. That means you can write triangle CAM is similar to triangle BAD, we can write. Okay. If two triangles are similar means what? Ratio of sides are proportions. You can use that idea here. So first you can take AC corresponding to AB, right? So AC by AB you can write. And the first and last you can take. First is what? MC divided by BD. Because corresponding sides are proportions, right? So from this, what we conclude? MC is equal to what? AC by AB into BD. Clear? This is the first one. Next, which two triangle you can take? The ultimate target is, you can see in the screen, this CD plus MD we need to find out. CM we already got it. We need to find out, MD here. MD or DC? DC is we need to find out, right? So for that, which two triangle you can take? Take triangle DAM and triangle A or BAC you can take. Okay, triangle DAM. Let's take another page. Triangle DAM and triangle B. Which triangle we are telling? BAC you can take. Okay. These two triangle, you can see which two triangle I am talking about? DAM and BAC. So one observation is what? By construction, angle 1 is equal to angle 2. Right? Okay. And one more angle is required. One more angle how to take? You can see the green color is there. No angle, green color is there. You can use that one. Exterior angle of a cyclic quadrilateral is equal to opposite of the interior angle. Okay. The first one, angle 1 is equal to violet color you take. Angle 1 is equal to angle 2 by construction. And second one, exterior angle of a cyclic quadrilateral is equal to opposite of interior angle. First one, you can see angle DAM is equal to BAC. Angle DAM is equal to angle BAC. That means angle 1 is equal to angle 2 by construction. Okay. Then you can see next thing, exterior angle. Angle, which one we can say? ADM. Angle ADM DM is equal to, so which one is this one? ABC you can take, angle ABC. So why this is true? Because exterior angle of a cyclic quadrilateral, exterior angle of a cyclic quadrilateral is equal to opposite of the interior angle. Okay, I hope everyone understood, right? So now you can see you can use the by angle similarity, what we can say, triangle GAM is similar to triangle BAC, right? So from this, which one we can take? AD corresponding to AB corresponding to AD, right? AD corresponding to, let me take another color, AD corresponding to AB, right? AD corresponding to AB you can take, is equal to the first and last you can take. MD is corresponding to BC. So what actually we need to find out is MD and CD. Okay. So from this MD, how to calculate? AD by AB into BC. So how to prove this? You can see, student, very simple here. Okay, we found the two equations here. One is what is that? MC, other one is MD. But MC how to write? You can see MC how to write, you can see in the screen. MD plus CD, right? MD plus CD, right? Okay. What is MC here? We found, no? AC by AB into BD is equal to MD. MD just now we got it, right? AD by AB into BC plus CD. So now you have to multiply by AB, both sides. Multiply by AB. So then what will get? AC into BD, that is the product of the diagonal, AC into BD. If you multiply the first term, AD into BC plus multiply to the last term, you can see AB into CD. Clear? So that is only we need to prove. You can see AC into BD, right? So AB into CD plus AD into BC, correct? AD into BC. Yes, we proved. That means the product of the diagonal of the cyclic quadrilateral is equal to the sum of the product of the opposite sides, right? We proved. It's a very simple proof using the similarity of the two triangles, right? Okay, fine. I hope everyone understood. Then let me take example. In a cyclic quadrilateral PQRS, PQ is given to you 6, QR is 2, RS is 3, SP is equal to 4. And the diagonal PR is equal to 5. Find QS. How to find out? Let's take a quadrilateral. Let's insert the quadrilateral inside the circle. Let's take the PQRS, right? P, this is P, Q, or S. Okay. PQ here is 6. QR is what? 2. And RS 3. SP is 4. Okay. So the diagonal, one of the diagonal PR is given to you, right? So you have to use the Ptolemy's theorem here. The product of the diagonal, what is that? PR into QS is equal to, let's take the opposite pairs, PQ into SR. And PS opposite is what? PS into RQ. Okay. What is PR? PR is given to you 5 into QS. We need to find out. PQ is what? 6. SR is 3 plus PS is 4 and RQ is 2. Therefore, 5 into QS equal to what? 18 plus 8. This is 26. So, therefore, QS equal to what? 26 by 5 is your answer. I hope everyone understood, right? So, in IOQM, they will ask the questions, what is the 5 times QS? So, you can say that the answer is 26, right? Suppose if they ask integer type of questions. Okay. So, I will give you for you this next question using the Ptolemy's theorem, how to solve these kind of questions. You can see the P is the point on the circle circumscribing a square. Satisfy PA into PC is equal to 56 and PB into PD is equal to 90. Find the area of a square ABCD. So, what you can do? First, you draw the circle and inscribe the square inside. Mark it ABCD and P is, you can take between B and C or any sides you can take. P is moving point, right? Anywhere on the circle, right? Okay. So, you have to construct and join to the vertices from P to vertices of the cyclic quadrilateral, and you make a cyclic quadrilateral, and then you can apply the Ptolemy's theorem. You can find the area of the square. So, I think you can take it as a homework or you can exercise. You can take it as exercise. So, we'll discuss in the next class how to solve this. If you able to solve, you can post your solution in the comment section. So, next video we'll discuss about the solutions and we'll discuss some other topic. Okay, I hope everyone understood. If you like this video, please subscribe my channel so you will get a update. New videos will be updated, right? So, who are watching this video, so please parents and students has to understand this channel is completely for 6th to 12th standard, the mathematics development oriented coaching. It is 100% results oriented coaching. So, you have to utilize this platform. Thank you everyone.